And I am awake, in spite of rumors to the contrary from people who fly in from Seattle. It's nice to see all of you, especially the students. So how many of you are students here? Wow, this is great. Seriously, I've gotten the opportunity to speak to many people, many students especially, in the United States, in Canada, in Korea, Brazil, Europe, various places. And that's one of the most fun things that I get to do in life. What I want to speak to you about today is understanding a little bit about what the analytics business means from actual experience doing that job. I mean, Mike talked about a lot of the foundations of analytics when he opened what it should be a wonderful center here at MYRA. We had a wonderful conversation before this, just about how the educational opportunities that you all are being presented are going to do things that will let you change the way the world works. Mike was correct. Oil is going to be depleted a lot faster than data, and I'll give you some of the ways that my aerospace company is having more and more data show up all the time, and how we need to have that data bring value to the company. So the big deal is, for all of you students, and I'm going to talk mostly to the students because you're actually the most important part of the entire equation. But let me tell you first a little bit about me. At one point in my life, I was cute, right? So you can get some idea. This is a wonderful picture that my folks took when I was a little boy in San Antonio, Texas, right? I've been around the computer graphics industry. I've been around computing for a long time. And in fact, I've been around for 50 years since my high school days in Denver, Colorado. So I graduated a long time ago. Just think about that in terms of all of your lives here as students. I've been involved with the field of computer graphics since 1969. I did things on a microfilm recorder that made computer animated films. It was a wonderful experience, and it led me to do the sorts of things that Mike and Sajid talked about already, that they want to be with places for a long period of time because they've had so much fun doing it. I've wanted to be involved with computer graphics ever since the bug bit me in 1969. I'm lucky enough to be a Boeing Senior Technical Fellow. So one of the cool things about analytics and data is that you can draw really weird facts. I was quizzing my colleagues before lunch, before this session, about how much energy, how much it costs to heat Boeing's Everett plant in Seattle, Washington, where we build 787, 777, 767, 747. It's a huge building. It's the world's largest building by volume by a factor of 2. Think about that. There are weather systems that form in this building. Seriously. So you'll get rain. There are people who drive trucks and cars and all sorts of things. And think about it, a factory, a plant that can have in it maybe 8 or 9 777s being assembled at the same time, the same number of 787s. It's huge. Now here's your question as an analyst. How much does it cost to heat and cool that building on an annual basis? Think about the air conditioners here in this building. And thankfully, at my hotel here in Mysore, the air conditioning is very valuable. How much do you think it costs? Any guesses? Come on, this is audience participation. One number. Anybody want to guess? No? It costs 0. Because the people who designed the building did some amazing analysis before the building was built. So a lot of the purpose of analytics is not just to do things after the fact, it's to do things before so you can make good decisions beforehand. So they understood how the wind blew. And during the summer they open and close huge doors so that the wind can blow through and cool the place down. And during the winter, it turns out that people like us provide a lot of heat, and so all the employees in electric lamps actually do the heating for the building all winter long. And fortunately, there's a roof, so all the rain in Seattle doesn't get into the place. So I am a Boeing Senior Technical Fellow. That's a really cool job in Boeing. And it's one of those things that I'm an underrepresented minority. There are now 65 Senior Technical Fellows in a company of about 160,000. So there aren't very many of us. There are about 400 Senior Vice Presidents. So there are fewer Senior Technical Fellows than there are Senior Vice Presidents. I'm also an ACM Fellow. So how many of you know what ACM is? Anybody know what that is? It's called, good, Shalini knows what it is. It's the Association for Computing Machinery. So I'm a computer guy. ACM is the oldest and largest association of computing professionals in the world. There are roughly 120,000 now, and maybe in less than 1% are fellows. Okay, so if you're interested in computing and following some of the computer science that leads to the analytics work that you're going to be learning about with Mike in the Smith Center, look at ACM for professional opportunities as well. Turns out that as I got older and became a Senior Technical Fellow, I became a stand-in on Starship bridges. Any of you recognize this guy? From Star Trek, The Next Generation? I'm actually a pretty good stand-in for Patrick Stewart. And the reason I love this picture is that it's the only picture that has ever had hair photoshopped out, so it could actually fit the profile better. I do a lot of work, as I said, both in analytics and visualization, as Shalini implied. I do a lot of things, and I've been involved with stereo virtual reality. I've been involved with augmented reality. I do a lot with geometric as well as non-geometric data. My talk today is mostly about non-geometric data. And we can talk about geometric data on a whole nother talk for a long period of time, if you'd like. But the big deal is that I understand what the implications of data growth are to what we want to do as our business. The reason that I'm here, and I think the reason that Mike and Shalini were kind enough to invite me, is that the Boeing Company builds some extraordinary aerospace products. Okay? We have all sorts of things that we do that have revolutionized the world. In fact, it is Boeing's 100-year anniversary this year, which is really quite cool. And the things that we've done have actually changed the way the planet works. I would not be here if it was not for Boeing 777s. But in fact, many of us would not have the internationalization that we have in the world today without the ability to fly from point to point on the safest mode of travel, which is commercial airplanes. Okay, Boeing gets involved not only in that, but in the upper right-hand corner, things like hypersonics. So a hypersonic airplane is fire it once, get it to about 5 times the speed of sound, let it drop into the ocean, recover it, and then figure out what you can learn for the next round, because you're going to build another one. It's fire once, never reuse. You can see some of the new commercial airplanes. We do lots of military things, and we're very grateful for India for the participation in the PAI program and other military programs. So we have a great relationship with, Boeing has a great relationship with India. And we do advanced technology like crazy, because the aerospace business relies on more insane types of technology than you can possibly imagine. So you all are getting a curriculum. You had a curriculum as undergraduates. You had a course catalog that you had to read, right? There are a lot of courses that you could possibly take. Well, at the Boeing Company, we have all of those courses plus probably 10 times more, because we need all of these technologies to actually make advanced aerospace products. They range everything from basic physics to our products themselves are just flying networks. We have people who deal in material science because we care how the materials react. So we do work with advanced composites, with 3D printed. We do natural language analysis because it's important to understand the data that we get from all of our customers, suppliers, all of the people who work on our products. If it is a complex technology, Boeing will have it or will have had it at one time. And we do things like hydrogeology. Anybody know what hydrogeology is? So this is part, so kind of get audience participation, keep you all awake. You know what hydrogeology is?
Water body.
What is it, Mickey?
Maybe something to do with water.
It's water. It's water as it interacts with the earth. How it flows through earth. Right? Yeah, it's groundwater and how it impacts the earth. Why would Boeing need a hydrogeologist on staff? Actually, there are more.
At high altitudes.
Pardon?
At high altitude, when a plane.
Couldn't quite hear you, sir.
At high altitudes.
No, this is water interacting with the ground.
The reason being, when planes fly at high altitudes, maybe the moisture, how it reacts.
Oh, maybe what happens when you flush in the lavatory? That's a different story. No, it turns out that what actually happens is that Boeing cares about that because we build, many of our products require toxic chemicals to either coat the parts for preservation, or we use during the manufacturing process. And during the 40s and 50s, when we were building all sorts of bombers and the like, some of that leached into the ground. We have to figure out how to clean it up. So we're actually being environmentally responsible with our hydrogeology staff. These capabilities and challenges have kept me a very happy Boeing employee for 35 years. So you've got 3 people who have 25 plus years of experience in terms of working with interesting companies doing interesting things because the work is always varied. That's not necessarily a suggestion that you have to be in the same place for that long. The point is that all 3 of us have had extraordinary adventures doing many different things under the same roof. It's amazing what you can do if you put your mind to it and want to move around. So just consider that as you go with your career. What's interesting though is that the same fact applies to all 3 of us. Data just keeps growing at an exponential rate. You all know about Bohr's law, where the transistor density doubles every 18 months and the price goes in half. Pretty much a linear curve, and has been that way since the late 1960s. What's interesting is that the amount of data is actually growing at an exponential rate. If you look at the last line, we're getting to zetabytes plus. This estimate was from 2011. The reason that I got into the visualization business and visual analytics is that what has happened to us in reality is that our human capacity has not doubled. Right? We're pretty much at the same level from a really long time ago to currently. So the big problem that we have is how do you gain value out of that data when it's growing a lot faster than our capacity is? The bottom line is that visual techniques help a lot. People gather about 80% or more of all information that they gather on a routine basis using visual techniques. So that's why I got involved in visual analytics. The real question is, not only can we, and most of you probably have heard the term analytics. It is one of the catchphrases of 2014 and 15. Right? That's why many of you are here. That's why we're starting programs in big data analytics. Because it's changed from an environment that is kind of a boutique sort of thing to something that's really important. The question is, how can we keep that momentum of analytics just growing so that it goes over the hype cycle and we actually have value? That's why your involvement in programs like Mike's is so important, because you will get the basis on which to actually make analytics succeed. Let me tell you a little bit about, first of all, can we learn something from the past? And companies like Boeing have been involved in computing, not quite as long as 100 years, but we've been involved heavily in computing since the late 1950s. And there are lots of things that Boeing has done. This is just a partial list on programs and projects that Boeing has accomplished and done extraordinarily successfully since the early 1950s. Okay. I won't go through all of this. So I'm going to keep moving on the analytics side. But it's important to understand some things from the way this history has happened. And I'll just give you one of my examples. Okay? So all of you know about computer graphics, I hope, right? Well, a Boeing person invented the term in 1960. His name was Vern Hudson. He figured out that it was much cheaper to produce plots like the ones that you see on the bottom. Contour plots, 3D to 2D plots. And he used a really interesting device in Wichita, Kansas to figure out how to do that. The lady who is sitting at that machine is responsible for figuring out how to get all of those drawings done. Using what kind of machine? Does anybody know?
Telegraphy.
No, it's not. It was not a teletype, actually. It was a key punch machine. A key punch machine. She actually sat down and she poked little holes into a piece of stiff paper. That was the input mechanism that was used to provide the data that allowed you to act, that needed to be visualized. It was a slow and arduous process, but it turned out to save the Boeing Company money, and ultimately turned out to be the basis for the term that Vern used for developing the term computer graphics.
It's
Pretty cool stuff.
IBM card.
Pardon me?
IBM card.
Right, an IBM punch card. I could tell you lots of stories about the past and computer graphics, but I won't do that. I want to look at what's going on in the present and what you can help with in the future. Boeing has done an awful lot in the fundamentals of computing. We've done things in visualization. We've advanced the state of the art, not only in a lot of aerospace things, but in computing as well. These are just some examples that were on the previous slides. What we wind up wanting to do is push the state of the art, so we can build and keep advancing the state of the art. It's a real big challenge. The lesson, though, is that we have had all of these projects that we've done in terms of computing. Okay? The dates change. They've been over decades. Right? Longer than I've been at the company, longer than Mike's been at Dell, and we've been at Infosys. What's important is to understand that really good ideas don't happen overnight. Okay, and there'll be some comments that I'll make at the end about what this means in terms of analytics. So you think about all of these concepts that Boeing developed, that many people have developed, and you realize that it took decades to come into reality. You all are in an extraordinarily exciting time, because you're really in the first decade of sophisticated analytics. You're going to be able to keep pushing that forward to make it more and more pronounced, so that it in fact becomes the commonplace thing that we do every day for all of us, and for all of us to help make better business decisions. Boeing got involved with text analysis really early on. We developed the things called the simplified English checker in the early 1990s, because it turned out to be difficult for people who didn't speak English to understand our maintenance manuals. And it's a really good idea for an aircraft mechanic to figure out how to repair an airplane so that you all can fly safely. So we tried to make things as simple in English as possible. And then a really cool lady named Ann Cow developed this thing called Trust in the early 1990s that actually is the result of the cluster analyses of understanding how to analyze that text to get more information. And we've done a lot of statistical work over the years. Right? You all will get some taste of statistics with Mike's curriculum. I got involved in the world of visual analytics in 2004 and 2005 when the actual research program was put together. So I was lucky enough to be the only real industrial participant to put together the way that visual analytics should proceed. And the whole field started from a terrible disaster that was 9/11/2000. The Department of Homeland Security actually invested a significant amount of money to make it easier for people to do analysis of complex data so that they could understand things better. Okay, so our thanks to Joe Keelman and many others. The idea of visual analytics is pretty straightforward. There is a formal definition. The science of analytical reasoning facilitated by interactive visual interfaces. This means other things, when you actually look at it. Mike described it fairly straightforwardly when he talked about analytics in general. Analytics in general just basically means that you want to use data to gather insight. You want to process things on more than intuition. Pretty important. There's a really important word in that formal definition. Okay, that word is interactive. The idea is that you don't want to just present charts and graphs with arrows and circles on the back of each one and try to give people those reports. The idea is to allow people, especially the analysis community, to explore the data dynamically and interactively. And it's amazing what you can find doing that. I'll give at least one example during the talk. Boeing's adoption curve has kind of been in parallel to what's happening in the world of a lot of the technologies that I described earlier. It has taken us a decade to get to where we are now. And we've done some fascinating projects. Our first project really started essentially in 2006. And what we wound up doing is trying to understand how birds, flying birds, affected airplanes. Because if you think about it, birds actually, we have two flying objects, and occasionally bird radar doesn't work and they run into airplanes. Boeing has on staff a bird strike expert. He worked with a student from Simon Fraser University and wound up doing some amazing things in like day-and-a-half sessions, understanding how we could improve our airplane products with respect to bird strikes. Really cool work, really interesting research. And that led to other work that talked about industrial safety. But that was 2006, 2007. It has been done in pockets for the last 5 to 7 years, and now it's a full-fledged boom inside in Boeing. Mike talked about the data scientists, maybe 1% or less unemployment rate, and the needs for additional people who are trained in doing this data analytics work. The reality is that that boom has hit Boeing and literally employing hundreds of people who are data scientists. It's really cool. The interesting part about analysis, now what I'm going to talk about for the second half of this talk, is a lot about what it means to be an analyst. Because many of you will get bitten by the analysis bug, and I want to give you some of the lessons that we have learned over the last 10 years. Stuttgart and Paroli from Xerox PARC came up with this analysis loop. And it turns out to be pretty important from a sense-making perspective. Because what you wind up doing is a number of things that gather data, right? That's the lower left-hand box. You put it into a shoebox and you consider that to be your evidence. You wind up building a schema, a suggestion on why you think you can work in a certain way. You apply some tools and techniques and form a hypothesis, and ultimately you have to come up with a presentation. It turns out that what this leads to is the first impediment that I'd like you to be cognizant of as you go forward as analysts. Okay? I'll talk about 5 impediments. What approach do you want to use as your analytics method? And there is an essential precursor. That precursor is that the first thing that you have to do is understand what the problem is. Right? Remember, in the analysis loop, you were building this shoebox. You were filling the shoebox up. But before you fill your shoebox up with data, you have to figure out what your problem is. And that turns out to be a hard thing to do. It takes talking to the people who are senior people, right, to understand what are the issues of the company. So So for example, how can you improve sales? How can you do things better? Once you understand the problem, you have to figure out what your analysis approach is. And this is something that I know will be big on in Mike's curriculum. Because that definition of the problem means that there are certain sorts of things that you will attack the problem with so that you can learn things like situation awareness. You want to understand what's going around you. The classic example of situation awareness is battlefield management or air traffic control. I'm really happy that we have air traffic controllers because they understand all of the components around them so they can route you better. Right? That's what situation awareness is all about. Tracking and visibility is a big deal. I don't know if this is commonplace in India, but it certainly is in the United States. I can track a package any place I want. Well, from an industrial perspective, it's really important that I understand how I'm getting parts in to my factory so that I can build airplanes properly. Right? There are lots of issues around that, but if I get that status and that tracking and visibility, it turns out to be a big deal. Boeing is really concerned in understanding why things happen. This is causal chain analysis. A lot of people will call it root cause analysis. Right? You want to figure out why a disease started. You want to figure out why there was an accident someplace. That's what causal chain analysis is all about. Hypothesis testing is one of my favorites, personally, because you think this is true, and then you either prove or disprove it. That's what hypothesis testing is all about. You want to detect anomalies and correlations. The reason that the Department of Homeland Security started visual analytics in the first place is that when you're sifting through large amounts of data, the human visual field is really good at figuring out where things are, when things are anomalies. So I can see things in the audience that I can't get a computer to do very easily and very quickly and very accurately. It's a big deal to do prediction and forecasting. So I've often wanted to predict the stock market so I can retire really early. So far it hasn't happened. I'm also trying to figure out how to predict the results of the current U.S. election. And if any of you have any insight into why Donald Trump is doing so well, I shouldn't say. I would be able to, I would really clean up somehow or another. But seriously, we want to understand how to predict and forecast things. Everything from the weather to the number of parts that we need at a certain time, to when a machine tool might fail. These are all big causes of problems. Or to when a part might be needed at an airport to fix an airplane.
I think rather than we do the analysis, the politicians themselves are gathering a lot of demographic data.
Absolutely.
They want to know how to attract the crowd.
Absolutely.
They're using all sorts of technology.
That is
win the
commonplace. I agree. So the idea is, how can we use data to predict how to get crowds for certain candidates? Right? That's commonplace. That's what marketing is all about. Right? So you should be learning that in your courses here as well. Boeing does a huge number of what-if studies. We want to understand what would happen to any of our products under certain conditions, under loads, under for computational fluid dynamics, so we understand how that airplane will fly. We understand how electromagnetic effects work. It's hugely important to understand that before we start building it, because once you build a product as complex as an airplane, it's really hard to change it. So all those what-if studies essentially allow us to weigh trade-offs and understand what's going to happen. The last one, I'll argue, it may be the hardest analytics task of all. And that is, how do you communicate the results of what you just found out to somebody who has to make a decision to move forward with what you've recommended? How do you convince your peers that what your analysis is all about is the correct analysis? How do you communicate to the general public about those analyses? Really a hard job and something that we don't spend nearly enough money doing. The next impediment is one that happens as you now, so now you've got the problem, you've got your analysis approach. Now how do you attack it? What tools do you use? And Boeing as a company, as I would imagine any large company has this thing called tool wars. And the deal about tool wars is that people say, my tool is good for all problems, and your tool is bad. I'm sure that's never happened to any of you in this room, right? Your favorite photo touch-up program is Photoshop, or you like something other, you like numbers on Apple rather than Excel, or whatever tools that you have. We'll get into arguments about it. All of these are examples of different tools. Visual analytics is another one. The important part to remember is that there is no universal tool, so learn many of them. Okay, because you will find that there are different tools that are good at attacking different problems. And this is just one mapping of tools that I know about that are mapped against those general types of analysis approaches. So think about that as you move forward. The next impediment is that as much as we think that Moore's law is keeping up with data, it's not. Data is just getting bigger, and we need more and better ways to deal with that data. It's a big deal. Boeing has huge amounts of storage. We have Hadoop clusters. We have database machines. We have database management machines like Teradata. We have Oracle systems all over the place. We have file systems all over the place. The big deal is that data growth just keeps coming forward as we get more sophisticated sensors in the world. Everything ranging from telescopes, which are just nothing more than radio sensors, to things that inside my company that are like wireless in the factory. So we can track things that are happening in this huge space in Everett to smaller spaces that use a number of different tools, a number of different technologies, everything from RFIDs to barcodes to unique identification schemes, using ultra-wideband networking and the like. It's really difficult to figure out how to gather all that data and understand how to put it into a place that you can do both real-time analysis as well as ex post facto analysis. It's really hard. Our products are nothing more, quite honestly, than flying computers. Same thing's true with automobiles. They're just basically global on a much smaller scale computer networks with lots of embedded microprocessors and sensors. A real change in the way that we do business. The interior slot is just an image of all of the electrical systems that are on a Boeing 787. 787 has 60 miles of wire. Right? That's about 100 kilometers of wire. Think about it. The A380, the Airbus A380 has about 180 miles of wire. There's a lot of connections and a lot of data gets generated that is for all sorts of applications, ranging from in-flight entertainment systems to cockpit control to the way the landing gear works. Everything is dependent on data, and that data is actually transmitted to the ground, and we'll see that in the slide after next. It also turns out that data affects our military airplanes as well as our commercial airplanes. It's a really big deal. Now, so the Osprey is a really interesting machine. It is a vertical takeoff and landing, but then it tilts the rotors, tilts the propeller blades, so that it will fly like a regular airplane. So it's not a helicopter. While flying, these systems will generate literally a 14,000% increase in data. It's just projected by the time, what is this, about 2030? 1 petabyte of data per flight. And we want to analyze that and do more with it. It's a real problem. The next chart I want you to pay really careful attention to as an impediment. and this is important for all of us in the room, independent of age or years of experience with the company. And that is the notion that data is a strategic corporate asset. And that means that if it's a strategic asset, you want to take care of it. You want to put it under configuration control. So in other words, so think about the problem. So first of all, if you think about it as an asset, it has to be about high quality data. Because if you move data from, let's say, from Mike to Shalini, and Shalini has to change that data and go back to Mike to check if it's real, or she has to tweak the values because they don't quite meet her expectations, it becomes a lost lead. You're not getting nearly the value out of the data that you could, and you might be computing on bad values. That's one of the things that we don't like as analysts. We want everything to be perfectly well behaved so we don't have bad values in our data. Well, that means that the people who are generating the data in the first place have to take some care in putting it together. It's an asset. Number two is configuration management. Okay, because whether you want to admit it or not, you will change the papers that you write, you'll change your analysis results. I change things all the time. But knowing that it's the right version is essential to do things much more effectively during the analysis process. So I could have been really embarrassed in giving you the wrong presentation today because I didn't have the data under good configuration control. But it's a really big deal for you to pay attention to as you're working, not only asking people, is this the right version of data as I'm doing my analysis task? Is the data getting stale? Remember, we're filling up a shoebox. Is the data getting stale? Do I need to refresh it? Because people somewhere else have been changing that data, and I might have the totally wrong picture of what's going on. Okay, so problems that we found inside a company like Boeing, and I'd suggest every place else, is that while the data is believed to be yours and yours alone, and can't be of value to anybody else. So think about that as well. So just a couple more slides, and I'll get off stage. So first of all, have we learned anything from this analysis? So let's go through each one of the boxes in that sense-making loop. First of all, gaining access to data is hugely difficult. Even finding the right data is difficult. Be prepared to spend time doing data wrangling, is the general term that's used now. A guy named Jeff here gives credit for that word. You have to determine efficient access methods as well. If it takes me 2 months to get to data that loses its value after a month, it's not really going to do me a lot of good for that analysis task. Pay attention. Keeping that shoebox current I just mentioned, there's a whole notion of data provenance. What do you think that means, data provenance? Anybody can guess about what that means? Say it louder. It's where did the data come from? So I don't know if you're anything like me, but I'm certainly guilty of this. Is that when I get data from somebody, I'll often want to copy it and keep it for my very own. Right? That's why we all have file systems on our computers, isn't it? Because we don't trust anybody else. And anyway, I want to tweak the data anyway for my purposes. And then I'm going to send it to Mike, and I'm going to send it to other people in the audience. And all of a sudden, I don't know what the actual real source of data is. So you have to be able to derive it. That's what provenance, data provenance is all about. You have to understand the data values. So technical companies, any company in fact, speaks in its own jargon. There are certain terms that get used in aerospace that I could talk to you guys about, like effectivity, like time-dependent effectivity, or data effectivity. You wouldn't understand what I'm talking about, let alone the vocabulary to define the field. But then you look at the contents of the field and you really don't understand what's going on. So you have to understand the data values, and you need access to a subject matter expert to help you with that understanding. Furthermore, you have to be able to derive and get what those problems are. Understand the problems before you begin your analysis. Remember, we talked about understanding the approach and the appropriate tools. A really big deal as part of your job as an analyst. Last, but by no means least, if you misconstrue because you've used the wrong way of communicating with people who need to make decisions, you could have done the best analysis in the world and you've lost anyway. There are classic examples of situations where that's occurred that include things like losing a space shuttle in the U.S. in 1984, like having satellites that get lost because people thought it was meters and the units were actually in inches. Really bad things that can happen if you don't communicate properly. So in summary, what I wanted you to all understand is to have a much better idea of what analysis is like, especially using visualization. You can tell I've got this, I have my biases, I'll be the first to admit it. I am biased towards visualization because we really do gain lots of insight in a way that is language independent. I'll also warn you that you can lie very easily with visuals. There are people who study things like change blindness and the like, and there are great examples of cognitive tests that your visual system is so in tune to the way things work that you can either detect misspellings pretty readily, or you can accommodate those misspellings fairly straightforwardly. It's amazing what our brains and the visual system can do. All of you are being trained to work primarily in industry. Using those visualization and visual analytics techniques is your challenge. It's Mike's challenge to prepare you properly. It's your challenge to use those techniques and actually make additional progress. It is essential for you all to remember that moving any technology into practice, to real practice, is a contact sport. You're going to have to work at it. It doesn't happen automatically. It's been true about visual analytics. It's been true about the entire cadre of technologies that I mentioned earlier that Boeing has been involved in. Be prepared to work at it. Be prepared to be patient. Even if your career takes you into different organizations, be prepared to start the battle and make sure that your view can be understood. Last but not least, Boeing has encountered this situation since I started working there, since I've been working there for 35 years. Our struggle is that scale kills. So all of the systems that you think your favorite salesperson is selling you will work perfectly at the scale your company requires is something that you have to invest in. Boeing breaks things at scale because our systems are so complex, our data is hugely complex, but they're still really cool products. And it's still really been cool to work there for the last 35 years. Thank you for your attention. And for those of you who care, I included some references at the end, so I'll make this available.
I have a question.
Yes, sir.
In spite of data mining and data analysis, and Dr. Gopal Singh mentioned.
Let's get the mic.
Hello, I am Dr. Gopal Singh, Professor of Economics.
Oh, good.
I have got two questions.
Sure.
Number one is that, in spite of this data analysis,
Yes.
and in spite of this computing and graphics that we have, you are also telling about we can detect anything.
I wouldn't go that far.
Yeah. My question is, just 2 years back, one Boeing aeroplane disappeared, and so far we are unable to detect the whereabouts of its disappearance. Nowadays the black box is very useful here. So how that can be solved? Whether it is like this Bermuda Triangle, something like that, which has been
Bermuda
decided.
Triangle.
I don't know.
There could be.
I don't know. What is the answer for this? That's number one. And number two is that about this. We are talking about this Pareto analysis.
Yes.
80-20 analysis. Yeah, how it can be used in this analysis, data analysis.
So Pareto analysis is one of the techniques that is extremely valuable for attacking some specific problems, right? One approach to specific problems. Remember, the approach is understand the problem, understand the approach you're going to take, and remember that the big deal in the Card and Paroli thing is looping back all the time. So you're always working with people who have the problem so that you make sure that your analysis is going the right way. So a Pareto analysis basically is a way of ranking things, and you move forward to understand things like hypothesis testing. It's a great, Pareto analysis is a great way of doing that kind of thing. So let's go back to this is MH370. And so I can tell you a personal story about MH370. But first, note that there has been a part of the horizontal stabilizer found in Madagascar. The guy was walking along the beach and happened to trip across it. No, he didn't quite trip. He was actually looking for parts of the horizontal stabilizer. So the actual point of fact is that the amount of data that is collected on a commercial airplane flying over water is actually pretty small, because the communication cost of transmitting data through satellites is something that the airlines don't want to pay. So there's a ping maybe every 5 minutes. Okay. The interesting part is as well that Boeing sent out, so I could do another talk on it's something called massive model visualization, but I think you all want to go and eat some dinner eventually. But we can actually look at the entire 3D model, and those 3D models were taken onto the Indian Ocean to help identify parts that they have come floating up. The one thing that is also important about the whole notion of analysis is to apply it in a way that is essential to preventing things before they happen. There are certain things that we have discovered, there's always a probability that something's going to happen. I think a better example would have been to prevent what would have happened with the German pilot, the German wings pilot, who was crazy. And the people who were around him weren't able to detect his psychosis. They eventually just flew the airplane into the Alps. Now, I think that's why the Department of Homeland Security started with visual analytics, so that people start getting this. But it's still early. We're only a decade into this. Right? We're going to do better. Will we be perfect? I doubt it. But can we get better? I think so. Okay. Any more questions? Yes, sir.
It is related. Good afternoon. My name is Rajesh.
How do you do?
The problem is related to homeland security.
So would you speak in the microphone? I want everybody else to hear.
The problem is related to homeland security.
Yes.
In order to prevent any disaster within any country, we need to capture data.
True.
It can be text, it can be visual, it can be video. Now, the data stream, which is in the form of bits and bytes, we need to extract certain information that it is related to extremist activity. And since the data is highly dynamic, what kind of computing mechanism, and in order to present it to the decision-making authority, how do we do this using these kind of tools?
Okay, so let me answer that in two ways. Okay, are you keeping going? So two parts of that answer. There is an emerging branch of analytics called stream analytics. Okay, I know people are working on it at Dalhousie, and there are others working on it, to be able to distill those large streams of data far more efficiently than we do today. So many of the analysis techniques that we use today are ex post facto. Okay? You're talking about real-time analytics.
That's right.
And then the precursor is how do you prevent something like MH370 from happening in the first place. Okay? So prediction is always hard. There's a probability of failure. Stream means that you have to be able to extract a representative segment of the data fast enough that you can do the analysis. Okay? It's in flight. It's not perfect yet. Okay, last but not least, what we're doing best is probably ex post facto analysis, where we're trying to then use it to shape inventory or do all what-if analysis and all. Okay, but it's something that will happen. The issue ultimately is that scale kills problem. Okay, because fundamentally what happens is that as you're gathering, because we can't process it all in real time, we have to figure out what the subsets are. And as I said, it's imprecise, it's not perfect. That's number one. Number two, that is a harder problem, I think, is to understand where to stop collecting data so that we don't become totalitarian states. Right? It's the issue in the U.S. obviously is personal privacy. It's when do you monitor people's cell phone traffic? When do you stop monitoring things? That is an individualist thing that means that that Homeland Security is in many ways similar to what business is all about. Right? Shadib would agree that a lot of what we do in business, what Boeing does as a business, is figure out how to manage, how to detect, ascertain, and manage risk, so that it does the least amount of harm to the fewest people, to most people. So we want to minimize that risk. The same thing's true with Homeland Security. And I have not been part of the Homeland Security crowd for about 5-6 years, so I can't tell you what they're doing right now, in the U.S. at least. Do you know anything?
There was a problem in front of us. This was 4 years ago. But the solution was not there at that time.
Yeah, it's going to keep evolving.
Yeah, India is talking to US in this regard, to other countries also.
Okay. All right. Any more questions? Yes.
I saw one slide. I don't know whether it's your slide or my slide, but the human capacity has remained more or less static.
Well, I'd argue in my case it's going downhill rapidly.
Yeah, and analytics capacity has really.
Well, that's computing capacity.
Computing capacity has
Yes.
really gone up. So, do you foresee in the other 50-60 years we become irrelevant and data analytics takes over and we become some kind of zombies or robots?
This is my science fiction question of the afternoon. So I happen to think that given all of the issues that we have with the data sources and the complexity and scale and amount of data, that human beings will continue being involved forever. I am not at the point where I believe the analysis techniques, because people are developing those analysis techniques. Therefore, those analysis techniques will always have limitations. They will have flaws. Okay. It will be asymptotic. It will approach it, but it will never get rid of it. Well, I think so. But that's a Dave Kasik opinion, and I have not seen situations. There actually is an interesting thing between that is whether a machine should control the ultimate decision about flight safety, about flight conditions for a person. Boeing is always on the person's side. Our European competitors are more on the side that there are situations where the computer should be in control. Boeing will always give control to the pilot. Our announcer.
Any more questions?
You can ask me questions later. All right? Seriously. It's much more fun that way. Yes, sir.
Yeah, my name is Sudhindra. I'm in charge of MIS at a local company here, BML. My question is about Tim Cook's what's happening between the FBI and Apple chief. At a certain point of time, the data becomes available to the government, and how Boeing is transparent on this data, or general policy, how much you let the government or even your competitor perhaps get access to this data.
So that actually is a really interesting. I'm going to answer that not with a direct line about Apple, because that's a fight between Apple and the Department.
Yeah, it's more on the consumer area.
But it's not. But there's the important issue that I think you raised revolves around data accessibility. Okay, so remember, I was preaching and pleading for people to give access to data, make it open. There are situations where it is essential for personal privacy, competitive issues, that you don't share data. So I will guarantee you that Boeing and Airbus cooperate fully on sharing data when it's a question of safety. And I know from personal experience that I've been able to get data to investigatory agencies to understand how airplanes work that we would not share under normal circumstances. So the circumstances will dictate how much that data is shared. But pre-facto, you have to understand that there are privacy issues in our democratic countries, India, the United States, etc., that will prevent sharing, and you just have to stop it sometime.
Because you also said data is an asset for your company.
It is an asset.
So you will draw the borders with its protection.
Yeah. So I know Boeing takes extraordinary measures to protect our internal data. The amount that I can't tell you the number of attacks, but my sources tell me that Boeing is the most attacked company in the world in terms of cybersecurity. So our cybersecurity guys do a lot of work. That's the other Full Employment Act, data scientists and cybersecurity. Okay, so if you're interested in that, I'm talking. But nevertheless, those safeguards are in place for a reason, and competitive advantage is competitive advantage, and a lot of it revolves around data.
Okay, my related question is also that you had the graph starting with the shoebox and data analysis.
Yeah.
In the whole gamut of that, you didn't bring the data security. Is the data security not part of data?
So data, it's part of data accessibility. Okay.
It involves both positive and also.
It's both positive and negative. Yes, you're correct. And thank you for pointing that out.
Yeah, thank you, sir.